So we've talked about chi-square goodness of fit, chi-square test for independence. Before we look at this example, as a refresher, any chi-square test is always categorical data. Goodness of fit is one variable only. Like if I looked at the distribution of hair color in this class, that's only one variable. If I looked at categorical data but two variables, that would be a test for independence. This is an AP problem from some year, I can't remember what year. So let's take a look. In September of 1990, each student in a random sample of 200 bio majors at a large university was asked how many lab classes he or she was enrolled in. The sample results are shown below. To determine whether the distribution has changed over the past 10 years, a similar survey was conducted in September 2000 by selecting a random sample of 200 bio majors. Results from the year 2000 sample are shown below. Okay, we good on the context? Great. A, do the data provide evidence that the mean number of lab classes taken by bio majors in September 2000 was different from the mean number of lab classes taken in 1990? Perform an appropriate statistical test using alpha equals 0.1 to answer this question. Okay, so it tells us that we need to carry out a test. It gives us alpha. This is how the College Board AP test is going to be worded. It's very specifically going to say carry out a test. We want to know, did the mean number of lab classes change? What test would we be carrying out to do that? Okay. What did we come up with? What kind of test would we carry out?
Hypotheses. Two-sample t-test.
Okay, I agree with the two sample, and I agree with the t, but that is not specific enough. Yeah, two sample t-test for mean. So in the end step, that's what I would be looking for. Of course, degrees of freedom, and alpha, which you're given, but ultimately that's what you're going to be carrying out, a two-sample t-test for mean. We're not actually going to carry out this test, but I do want us to get the p-value just to make sure we know how to do that on the calculator. So here's what we're testing. We are assuming that the mean number of lab classes in 1990 is the same as the mean in 2000. We want to know, is the mean in 1990 different than the mean in 2000? What I want right now is I want you to take 2 minutes in your group and do this in the calculator. All I want is the test statistic and the p-value. I would like to point out on the problem that off to the side you are given the sample mean and standard deviation for both samples. Please use those. So take 2 minutes with your group, figure out what is the test statistic and what is the p-value. Here's what I got. I got a test statistic of negative 0.75 and a p-value of 0.45. Can anybody verify? Yes. So I went to stat, test, two-sample t-test. Okay. Questions? Are we good? Okay. So for a test for mean, you use the sample size, not the number of categories. Number of categories would be for chi-squared. Does that answer you, Laura?
Yeah.
Okay. Remember, when we get to AP review, which is like a week from today, you can use your calculator for everything for these tests. So it's important that we know which functions to use. Maddie?
Do we have an AP review to do this week or no?
I decided not to give us an AP review this week.
Okay.
Does that work for you all? Great. Okay, this was all just review so far. Any questions before we look at the next part of this question? Okay, do we recognize though in part A that you would have needed to do a full phantoms? That I didn't have you do that, but on the AP test, College Board expected a full phantoms. let's look at part B then. Does the test in A address the question of whether the distribution of number of lab classes was different in 2000 than it was in 1990? If so, explain your reasoning. If not, carry out an appropriate statistical test. Okay, so in part A, we would have failed to reject the null, so we don't have evidence to believe that the mean number of lab classes changed. Does that address the question of whether the distribution as a whole has changed?
Going with no based on the fact with
Your inflection.
Yeah.
All we did was compare the mean. Does that mean that the number of people taking 0, 1, 2, 3, 4, 5 lab classes stayed the same? No. So did we address this question? No. If not, carry out an appropriate statistical test. So in part B, we are now carrying out a different hypothesis test. This seriously was a question on College Board a few years ago. Okay, so here's what we are doing. When we are saying a distribution, when we are comparing two different distributions, this is a chi-square test, and it's called a chi-square test for homogeneity. You'll hear it pronounced either homogeneity or homogeneity. They're the same. But that's what this test would be. What this test does is it compares two distributions. And it wants to know, did the distribution change? Generally, you are looking at 2 different years or 2 different groups of people. In this case, it's 2 different years. We're comparing people in 1990 to people in 2000. That tells us it's a chi-square test for homogeneity. Again, we're looking at, did the distribution change? Like I said before, this is carried out almost exactly the same way that a chi-square test for independence is. The only difference is your null and your alternative. That's it. If you remember, chi-square test for independence, there is no parameter. We start right at h. We are assuming no difference. So our null is that there is no difference in the distribution of the number of lab classes in 1990 and 2000. The alternative is there is a difference. In the distribution of the number of lab classes in 1990 and 2000. Everything else is exactly the same as the test for independence. First assumption, we need to have random samples. This case it's plural because 2 separate samples were taken, one in 1990, one in 2000. This was stated. Second assumption, we need to have a large sample. Those expected counts have to be at least 5. Here's what I want to address. Do you remember from before break that for a chi-square test for independence, I showed you how to calculate the expected values, but then I showed you that the calculator will do it for you. And do you remember how we put a matrix in the calculator that was a 2x2 table, or it had two variables at least? So you should be asking yourself, how do I do that if I have two different tables here? I have 1990 and I have 2000. What you do is you put them together. So I'm going to do this off to the side. Normally, you're just going to have one table of observed values. I'm going to put the 1990 in one column. So that's 28, 62, 58, 28, 16, and 8. So those are all the observed values from 1990 that I just copied down. From 2000, it's 20, 72, 60, 10, 26, and 12. So those are the observed values. What I want you to do right now is I want you to take 5 minutes, let's say, and get as far as you can with the rest of this problem. Come up with the expected values, do your step N, come up with your p-value in your group. I'm going to give you until 2:20 just to get as far as you can get, and then we'll come back together. Sound good? My biggest concerns, did we get the correct expected values? Did we? Did it throw anybody off that the numbers were the same between the two columns? Why is that? Okay, expected to stay the same. Yeah. The reason, when you calculate each of those, it's row total times column total divided by grand total. Do we recognize that the row total is the same for these two numbers? Right? The row total is going to be the same in the table. The column total was the same as well for each column. 200 people, 200 people. Remember that I do want work for at least one of these. I don't know what the numbers are. Row total times column total divided by grand total, though. N step, it's always upper-tailed. It's called a chi-square test for homogeneity, or like I said, you might hear homogeneity. Make sure you put the degrees of freedom. If you don't remember how to calculate that, just take it right off the calculator. There's your test statistic, right here, 13.82, your p-value, and we're going to reject the null. Sylvia?
Where the dot is, do you need to put work there and just do the first and last?
Yeah. Yes. So I do want a substitution here. I just didn't have enough room, so I didn't do it. Okay. I would like us to write the first sentence of the conclusion. We okay with that? Okay. Based on my analysis, I reject the null and instead believe the distribution of number of lab classes is different in 2000 than 1990. Different, or you could say the term has changed. And then the second sentence we've written a few times, so I'm not going to write that one. We're going to take a few more minutes to look at part C. We're not going to do it, but we're just going to look at part C. The biggest thing I need you to understand with this test for homogeneity is you use it when you have two different groups or multiple groups. If multiple samples were taken, either different time periods or different groups of people, that's a test for homogeneity. If it's a single sample, that's a test for independence. Part C, real quick. Use the results of your analysis in A and B to write a few sentences that summarize how the distribution of the number of lab classes did or did not differ. Use appropriate graphs to help communicate your message. What you're supposed to get from here, based in part A, the mean number of lab classes probably didn't change. That's what we got from our test in part A. The mean number of lab classes, we have reason to believe, didn't change between 1990 and 2000. But the distributions as a whole did. You guys with me? If you were to look at two different graphs, like what kind of graphs would be appropriate here to construct? Histogram. We would look at probably two different histograms. One for 1990 and one for 2000. What you would see is you would see that the centers are the same, but the distribution of the bars are different. So while the average stayed the same from 1990 to 2000, the number of classes taken, lab classes, did not stay the same. And again, that's what you would see if you were to look at the histograms. The centers would stay the same, but the general bars would be different. All of that was worth 4 points. It's pretty rough, right? Now, here's the good news I would like to tell you, is this question was from 2002, and I've never seen another question that has asked for 2 hypothesis tests. That being said, you very well could get 2 hypothesis tests on the AP test, and you probably will. Or you might get 1 hypothesis test, 1 confidence interval, but they're going to be different questions. They're not going to be in the same question. I have like 3 more minutes of talking to do, and then you all are going to do some examples. The next page I have, you don't have, so just look up here. I want to show you the difference between this example that we just did and the examples we did for independence. The first example we did, the calculator one, that looked at the relationship between gender and political party. You cannot just go off of the fact that it says relationship. So sometimes people will see the question, are blank and blank independent? And they say, oh, automatically it's a test for independence. You can't do that. In this case, in the first example, it was 1 sample. 1 sample of 300 people. Each person was asked, what gender do you identify with and what political party do you identify with? 1 sample. The Titanic one, 1 sample. What class were you in? Did that person survive? 1 sample, though. The last one had to do with the county hospital and being satisfied with health services. Again, 1 sample. Any case where it's 1 sample, you're going to do a test for independence. If it is multiple samples, that's a test for homogeneity or homogeneity. The reason I'm telling you this or really emphasizing it is for 2 reasons. One, recently over the past few years, the College Board has really loved the tests for homogeneity. So those have come up pretty often. There was a question a few years ago that asked, are blank and blank independent? But it was a test for homogeneity. So please don't go off of that terminology. Here's what you all are doing. This. I think this is in your packet. Can you look and see if it is?
Yeah.
It is. Okay. All you're doing, it's 3 questions. I just want you to read the question and tell me, is it a test for homogeneity or a test for independence? Take, let's say 5 or 6 minutes, do that in your group, and then we'll come back and go over it together. First one, what did we say? Homogeneity or independence? Homogeneity. Homogeneity because it is separate groups. There was a separate sample taken of soccer players, non-soccer players, and non-athletes. Second question, what did we say? Independence. Single sample taken. Third one also should have been test for independence. That go okay? Okay, questions for me? Because again, it's a single sample. So we took a sample of 450 people that were then classified by class standing, and body art.